Continuing with our discussion on private key cryptography, in this lecture we shall be looking at some of the practical encryption decryption algorithms which have been used or which are being used. So, the topic of this lecture is private key cryptography, the second part. Now, as I said, here we shall be revisiting some of the practical algorithms which are used in real scenarios. The algorithms that we will be talking about are data encryption standard or DES, triple DES which is an extension of that, and the most recent one which is most widely used nowadays is the advanced encryption standard or AES. Okay. Talking about the practical algorithms, there are numerous algorithms in fact. If you look at the literature, there is a lot of research going on in the development of new algorithms. There are good features in these algorithms, there are weaknesses, there are drawbacks, but these cryptographers or the persons who are developing these algorithms, they are continuously trying to come up with better and better algorithms. So, data encryption standard was one of the algorithms which was proposed earlier in the 80s, where the block size was 64 bits. So, it encrypted 64 bits of data at a time and the key size was 56 bits. This DES was used for quite a significant amount of time, but because the key size is not that large, 2 to the power 56 in the present day context is not a very large number. Using the fastest computer with brute force technique, you can generate all these keys and you can mount a brute force attack. So, there are other algorithms which have been proposed. This idea is one of the algorithms which have been explored. Here also the block size is 64 bit, but the key size has been enhanced to 128 bits. But as I said, the most widely used symmetric key or private key algorithm today is called advanced encryption standard or AES. This is also referred to as Rindal crypto system, taking a cue from the names of the inventors. Here the block size is 128, but for the key size we have a choice. You can have 128, 192 or 256 bits depending on the level of security that you want in a particular application. Okay. Larger the key size, higher will be the security. So, let us briefly look at the data encryption standard first. So, as I said, at one point in time this was most widely used. This is also sometimes referred to as data encryption algorithm or DEA. As I said, it is a block cipher which handles block size of 64 bits and the key size is 56 bits. So, if you have a longer plain text, then it will be split into blocks of 64, but in general the last block can be less than 64. So, there will be some additional bits added to it called pad to make this also 64, and accordingly using this algorithm the ciphertext will be generated, right. This is how it works. Now I am not going into the detailed explanation of how these are designed. So, I am showing you the overall schematic, how this DES is internally and what are the kind of steps that are being carried out to encrypt a given plain text. So, as I said, this is a block cipher with 64 bit of plain text. So, that 64 bit number is coming here at the top, and on the other side I have the 56 bit key that is coming here. Now, you see in DES there is a concept of a round, there are 16 rounds. In 16 rounds you are carrying out similar kind of calculations, but 16 times one after the other. So, what is the kind of calculation? First, this 64 bits that is coming, you do an initial transposition, jumble up the order of the bits. This is called initial permutation. Then this initially permuted value will go through the 16 rounds. Then you do a 32 bit swap, because you have 64 bit number, you take two 32 bit chunks and interchange their order. The last you bring it to first, the first you bring it to last. And then again whatever permutation you used here, you use a reverse input permutation here, the reverse permutation here, and whatever comes out, that will be your 64 bit ciphertext. But another thing you see, each of these rounds is dependent on another factor which is coming from the right side. These are the so called round keys. The value of the round keys are different, not the same. Although the value of k is same, PC is a permuted choice, some kind of key permutation is going on, and first permutation, then LCS is left circular shift, this key is undergoing a circular shift left, and using some combination function you are generating the round keys. So, round keys are changing with the round number. So, you see it is a quite complicated process through which I am generating this ciphertext from the plain text. Now, each of these rounds I am not going into the exact functionality, but broadly speaking what happens in these rounds are like this. You see the 64 bit plain text that is coming and is going through each of the rounds, if you divide it into two parts, you call it a left part and a right part. So, at the ith iteration, the left part is copied with ith part. So, in the after a round, let us call it L I minus 1 and R I minus 1. So, when you generate the output of this round, this will be your L I and this will be your R I. So, whatever this was here, this will get copied to L I, L I equal to R I. But in this R I, you have a function, this left part bit by bit exclusive OR, some nonlinear function. This is a complex function of not only R I minus 1, but also the round key that is coming from the right side. So, this R I is computed in a complicated way, and any crypto system which have this kind of a, you can say, structure, there are many crypto systems based on this structure. This is called in general Feistel structure. Okay. Now, as I said, DES as such is good, but the only concern is the short key length of 56 bits. For critical applications, we need keys of larger sizes. So, the first attempt which was done, or you may say explored, is to use multiple runs of the DES algorithm to provide greater security. So, here you have an algorithm which is referred to as triple DES. As the name implies, triple means you are using DES 3 times for every encryption. So, what you do? There will be 3 different keys, 56 bit keys for DES, and there will be 3 executions of the DES algorithm for encrypting every 64 bit plain text. For every 64 bit plain text, to encrypt it into a 64 bit ciphertext, you will be requiring 3 executions or 3 runs of the DES algorithm. The drawback obviously is your method will become 3 times slower, but the advantage is that you are using 3 56 bit keys, 56 multiplied by 3, that is essentially your strength of the key, you can say. The way it works is that from the plain text you apply the first key, carry out the DES encryption process. Well, Decryption I have not shown, decryption process is also quite similar, but the rounds are executed in the reverse order. So, whatever comes, you run the decryption algorithm with key k 2, and whatever comes you again run the encryption algorithm with key k 3. The point to notice that any data, if you apply the encryption algorithm followed by the decryption algorithm, you will get back the same thing. Similarly, if you apply the decryption first followed by encryption, then also you will be getting back the same thing. So, this principle has been used in structuring this order of execution, and as I said 56 multiplied by 3 is 168. So, effective key size is 168 here. Pictorially it works like this. For encryption, the plain text is coming, first you do an encryption with the first key k 1, then decryption with k 2, then encryption with k 3, you get the final ciphertext. For decryption, you do it in the reverse order. In the last step, you did an encryption with k 3, you will do a decryption with k 3. In the middle, you did a decryption with k 2, you do an encryption with k 2. Here, you did an encryption with k 1, you do a decryption with k 1. So, in sequence, in the reverse sequence, encryption decryption will cancel out, and finally, you will be getting back the plain text. This is how DDS works. DDS has been also quite widely used. In fact, in many of the money ATM machines, DDS was used till some time back. Okay. So, this was quite widely used. Now, there was a need for a new standard which was understood and identified, because DES was used for a pretty long time. There was no apparent weakness in the algorithm, the only concern was the key size was smaller, and many theoretical attacks designed by mathematicians were published, which reduces the complexity of breaking DES. So, DES was no longer considered to be very secure. Well, of course, DDS is an option, but 3 executions of algorithm for every single encryption is too much of an overhead. Okay. So, that also is some kind of a drawback. Now, the standard organization NIST in US, who actually standardizes the cryptographic algorithms, they came up with a call for ciphers in 1997. They asked the mathematicians and scientists to publish their algorithms. There will be like a competition, they will be selecting the best of them as the next generation standard for encryption. So, in that way there were 15 candidates which were finally accepted in 1998, 5 were shortlisted, and finally the Rindel crypto system was selected as the advanced encryption standard, in short AES. Sometimes we refer to this algorithm as just the AES algorithm. Okay. Today this is one of the most widely used symmetric key algorithms that is being employed or deployed in many applications. So, some features of this AES crypto system. Now, this I have already mentioned earlier. Block length and the key length, well, in the original Rindel proposal which was submitted, both the block length and the key length can be independently chosen to be either 128, 192 or 256. But when NIST accepted the proposal as a standard, they added some additional constraint. They said that, well, let the block length be only 128, let us not have flexibility in the block length, but let the key can be either 128, 198 or 256. So, although the original Rindel standard can have variable block sizes, but AES will have only 128 bit block sizes. The advantage of this method is that they are very easy to implement both in hardware and also in software, and there has been lot of attacks which have been attempted, theoretical and hardware based attacks, but still today this algorithm is known to be resistant against all known attacks. So, it is a good and safe algorithm to use, you can say that. Okay. So, very briefly let us try to understand how AES works. The first thing is that depending on the key size 128, 256 or 192, the number of rounds similar to DES can vary. Now, this table here shows that if it is 128 you need 10 rounds, 192 you need 12 rounds, 256 you need 14 rounds. Okay. This table shows you that. The rounds are identical except the first and last one where there is a small change that I will show, and each of the rounds there are some basic operations which are carried out. What are the basic operations? First operation is a substitution operation which is referred to as sub bytes. Here every byte, you see block size is 128. So, there will be 16 bytes. So, every byte is substituted by some other byte. There is something called substitution box which is there inside. Using the sub bytes function, it replaces a byte by another byte. It is basically a permutation function. Then there is something called shift rows, which is a transposition. The order is made different. The bits are not changed, but order is made different of the rows. Then there is a mix column operation where different columns using some operator, you combine the columns, mix them up in some certain way. So, there is a complicated functionality here. Okay. And finally, add round key. Similar to DES, round keys are also generated here, and whatever that 128 bit value is coming, you do a bit by bit exclusive OR with this round key to generate the 128 bit data for the next round. So, this diagram if you see, it gives the overall schematic. You start with the 128 bit plain text which is coming. These are the rounds, but before starting with the first round, you do a pre-round transformation. There is an initial transformation. After that, there are the rounds. The last round is slightly different. So, you see the first round is different in the sense that there is something done just before that, and similarly the last round is also slightly different, and there is a key expansion module in the other side which takes as input the key 128, 192 or 256 bits, and it generates the round keys similar to DES. This is how the structure of AES looks like. Now, if you look into each of the rounds excepting the first and the last, so the rounds, these 4 functionalities occur in this order: substitution bytes, followed by shift rows, followed by mixed column, and finally add round key, where the round key is bit by bit exclusive OR with this number. And another thing, the 128 bit data that you are having, that you are encrypting and you are moving at each stage, this is actually represented as a state vector. There is a 4 by 4 matrix. There are 16 such states, and each of them is an 8 bit quantity. 16 into 8 is 128. So, that is how this state is maintained, and all these operators are defined on that state matrix. That is how it is defined in AES. And looking at the overall picture, so here you see that in all the rounds these operators, as I said, are applied in sub byte, shift row, mix column and add round. In the first round, there is an additional add round key in the beginning, and in the last round there is no mix column states, only sub byte, shift row and add round. This is how it is done. You see, the structure, as you can see, is fairly complicated, but these 4 basic functionalities I talked about, sub bytes, shift row, mix column and add round key, these are defined in such a way they can be implemented very easily, both using some hardware circuits, also using some instruction set of a computer. They are efficient to implement. Okay. This was one of the objectives of these algorithms, how fast they can be implemented, what is the maximum speed they can offer in various implementations. Okay. So, with this we come to the end of this lecture, where we have talked about some of the practical private or symmetric key algorithms. Now, as I said, whenever you are trying to secure a network, you find that there are some vulnerabilities. There are a number of ways you try to secure your infrastructure, your data or files, whatever. Now, this encryption is one of the very commonly used tool or technique to provide you with the required level of security. You think of emails, you are sending mails, some mails may be quite confidential. You may want such confidential mails should be automatically encrypted, so that no one should be able to tap my messages, my mails. So, these encryption or decryption techniques can be integrated with other applications in a suitable way, so that they can provide you with some levels of security as desired by some applications. In the next lecture, we shall be starting some discussion on public key crypto systems and what are the methods that can be used there. Thank you.